Hello everyone, welcome back to the day 23 of Advent of Cyber 2024 of TryHackMe. So we have almost reached to the final end of the Advent of Cyber. Today is day 23, which is the last second day of this event. And today the topic is about hash cracking. So what is hash cracking and what will we be covering in today's video? You will get to know that in some time. But before that, let's just get into the story and understand the context of what we are dealing with today. Okay, so I'm excited. Let's dive in. The story. As time went on by, something seemed funny. Mayor malware and the source of his money. Sockmas grew closer, so the glitch better move it. Gain access to the vault so that he could prove it. Glitch has been investigating how Mayor malware funds his shady operations for quite some time. Recently, the mayor disposed of various old electronic equipments. One was an old tablet with a cracked screen. Being an avid connoisseur of an active and passive reconnaissance who does not mind dumpster diving for greater good, Glitch quickly picked it before the garbage truck. Surprisingly, despite being a terrible condition with a cracked and a hazy screen, the tablet still turns on. Browsing through various files, one PDF file that caught his attention was password protected. It is time that you work with Glitch to discover the password and uncover any evidences lurking there. So now the Mayor malware is the target of Glitch. So Glitch is trying to look at all of his shitty funds, where and all he gets those money from. So he saw and got to know that Mayor has just recently disposed some of his electronic equipment. So that's why he goes to the dumpster. Dumpster diving is a term used for gathering or going to the waste kind of environment of your target or your victim, and then you go and look around for any of the potential things that they've thrown away, which could be very sensitive, and unknowingly or unknowingly they have disposed such items which can give the attacker some information for what exploiting them or getting to know more about their victim. So that's what is dumpster diving. And Glitch is good at it because he is a very good hacker with active and passive reconnaissance skills with him. Now Glitch picks that tablet and he sees that despite that being in a terrible condition, you can still use that. And in that, he finds some PDF files which are suspicious and which is something fun that we'll be cracking today because it has some passwords in it. Okay, so let's dive in into understanding about passwords, what are passwords, hashes, and all those things. So that's what is our objective today, which is to learn about hash functions and hash values, saving hash passwords, cracking hashes, and finding password of a password protected document. So that's what we'll be dealing in today's video. So hash passwords. So what are passwords and what are hash passwords? Now, passwords is something which you will keep for securing your accounts and all those things. Now, whenever you sign up for an application, you usually give your username and a password to identify it to you. So you'll have an identification with the credentials and usernames and all those things. Now, before the latest regulations and all those came up, long before that, before security was considered as a big issue in the industry, people and organizations, they used to keep their passwords in plain text in their databases. So whenever I used to sign up in any website or web application, my username and password was present there with a clear text format. However, I wrote it in the ASCII format is going to be saved in their databases. Now you can see how big of a risk it is now with the recent data breaches, recent data leaks and all which are happening. Our passwords, if they're present in a clear text format, and even though we say as a best practice to not reuse passwords, even if the users are reusing the passwords, you can get them in a clear text format, and then as an attacker, I can try to compromise the victim's other accounts which might be using the same passwords, right? So those were the security risks that we were facing. For that, we came up with the solution of encrypting the passwords. Now, encrypting the passwords means that we'll be converting the passwords from clear text to something which is going to be hashed that cannot be retrieved back. Okay, for even retrieving it back, you need to have some other kind of informations like the salt and the algorithm which was used for making that hash and all those information. Only with those informations with the attacker, they can guess for the password but never can get the password from the hashed value. That's what came up with the modern revolution towards hashing of passwords. Now, how is that done? As we all use now the modern day technologies to hash these passwords. They are all pretty much mathematical equations which are running in the backend, or those logics were used. Now it's all digitalized. So those logics are going to be converting the original text into something which cannot be retrieved back. I can give you all an example of this. Now let's consider a integer value which is 3, and let's consider a reminder 2. There can be x number of values in the integer number line which can give me the reminder to be 2 for uh, any value of x on the integer line. For example, I can have the number 5 as x, so 3 divided by 5 or 5 divided by 3, I can get the remainder as 2. Now I can have some other values similar to this which can give me the value to be 2 as the reminder. Now just by having the value as 2, I cannot get to know the x and y's there. So same thing happens with the logic of hashes. Once you convert the hashes of the passwords, you can never retrieve it back. Now, the popular algorithms that we are using in modern days is the SHA-256 secure hashing algorithm 256. In short, SHA-256, which creates 256-bit hashed value for each word which is there in the file or name or whatever we give. So they've given us an example of how a hashed password will look like irrespective of the content size what is present in the directory. So the hello.txt file is a pretty much small bit. Yeah, it is 13 bits of a size file, and the one which is Feroda workstation live whatever, that is a 2.3 gigabit of file. So even though that is the variation in between the size of the file, we can get the hashes of them to be exactly 256. So they've given the example there and all those things. That's why having the passwords being secure is more important. Now, the way how passwords are saved is not just by the password being hashed with any of these algorithms, but they are also initiated with some salts. What happens is with the password, you're going to be integrating with some random characters, integers, or special characters with it, and then passing it through the algorithms, you're going to be generating the hashed value of it. Because if I might be using a password which might be common or something like that, but the hashed value should not be matchable or easily guessable by using the same algorithm. For that, we can use salt, which is going to make it totally random and totally unique for the hash value to be generated there. That's why we use salts while hashing the algorithms, while hashing the passwords using the algorithms. So, password protected files. So password protected files are basically something that we use for securing the files, folders, or file systems in our computers. Now they've given us an example of the data in transit vulnerability that we exploited in the day 14th, where while the data was being transferred from point A to point B, we could intercept it and then look at the data in clear text, or we could even decrypt the data and then look at it. Now, what about the computers which are there? Imagine my laptop contains some sensitive information which I don't want anyone to look at. So I can protect it with password. So that is what is data at rest, which is being protected. So because this the laptop's data is not being transferred anywhere, it is in rest. So I need to be protecting those informations also. In case I forget to lock my screen and then just walk away, and there's some password or there's some file which contains corporate details. So I need to be keeping it with a password protected security for protecting all those corporate details and all. For that, we also have encryptions and password protected algorithms, which is going to be keeping our files secure with passwords. So it uses the similar logic behind encrypting and saving these files. Coming to passwords. Now, the majority, you can open up any survey which was done in the recent years, you can see the complexity of the password still remains to be very much simple for majority of the people who are using passwords in day-to-day life. If they're using any website, they're going to be having one of these passwords as their password in their application. You can see the word QWERTY, you can see 123456 password as their password, or 1111 as their passwords and all those things. Now, the thing is, humans usually tend to keep something which they can remember easily. Now, that can be their name, that can be their date of birth, they can be the year that they graduated from college or university, or the year that they got married, or the year that they got the child, or whatever such information that they can easily remember, their parents' name, the location that they were born in, the first pet name that they had, or the pet's name which they have, or it can even be their house name, the address, or something like that. People keep something which is similar for them to know, and something which they can easily guess while they're saving their passwords. So here they have taken an example of the Maya malware. His password could be something like F1UFFYCAT, like fluffy cat, or fluffy 2024, or Maya 2024, because it's all something which he would potentially keep by having his pet called Fluffy. That's all the possibilities which are there in passwords. So it's always the best practice to have a secure password. We don't recommend to have passwords anymore. Rather, we say it is better to have a phrase. Just like an example, like I went to the beach last Wednesday with my cat holding in my right hand. Okay, that's a big set of characters. One, it increases the complexity for any of the modern day computers to just crack them. Second, that combined with the hashes and the salts is a big hash to actually crack, and no one can just guess that immediately. And moreover, if you have your own spelling errors in between them and changing the characters from A to 4, or at the rate symbols, or I to the exclamatory marks, and all of your creativities in the password, that's going to be very complex for anyone to crack. So, as a best practice, don't keep passwords, keep passphrases for keeping yourself secure. So, enough of the theory. Let's just dive into the practice. Let's click on start machine. That will give 2 minutes to load up. I guess we could have done that and then gone through the explanations of whatever all these things were. Now it's okay. Let's give it some time to load up, and let's see what we have for today. Let's read through the demonstration here. Maya malware had an online account in one defunct firm that was breached, and all its user data was leaked. After checking online, we were able to retrieve the mayor's password in hashed format. It is listed below. So mayor's email ID is mayor@email.thm, and we have the hash here. Can I see that hash in full screen? I mean, like, is the hash complete, or is it yet to be seen? I don't know. Let's wait for some 10 seconds to get to know that. We want to discover the original password. The first step in our approach is to figure out the type of hash function. Then we will try to hash different passwords from a password list until we find a match. We have saved the above hash value in the home user AOC 2024 hash1.txt file for your convenience. Okay, so the machine has booted up. So here we are just left with the terminal, and they've said that the hash is already saved. So let's see our working directory. So we are in the users directory. Let's go to the directory called AOC. The network connection to TryHackMe remote server appears unstable. Not from my side, I guess. I'm not able to interact with the box. Okay, please reconnect. Okay, let's clear the window. Now the window is up here. Now let's go to the directory called as AOC 2024 and we can see the file hash1.txt. Let's print that out on our terminal, calling it as hash1.txt. Okay, I just was too early with that. Hash1.txt. Press enter. Yeah, so this is the hash. Of course, this was empty because I mean half completed because I thought looking at the length of it, telling that it might be half in length. Okay, so we have the hash in here which we need to be cracking. So first we will go to the AOC directory and then display the contents of it. Copy the displayed hash. Selecting the text in the split view will copy for you. Next we start one tool that helps to identify the hash by issuing the command python hashid.py. So do we have this file? Yes, we have this hashid.py file. So let's run that command. So python hash id id.py and then paste the copied hash. So let's select this, which technically copies it, and then let's paste it in here and then let's press enter. So it says the possible hash is SHA-256 and one. What is this about? Okay, we need to press Ctrl C to kill that session. That's done. So we know that now the algorithm which was used for generating this hash was SHA-256, which is secure hashing algorithm 256. Okay, that's good. Now what shall we do? Next, we will try passwords from rocky.txt, a popular password word list from a real data breach. The command is follows. We'll be using John the Ripper for cracking this password. Okay, let's do that. So let's clear the window and type in the command John, which is the tool's name, which is John the Ripper. And then let's select the format that we want the algorithm to be used for cracking this password, which is going to be format. And then we'll specify it to be raw, then SHA-256, then hyphen. We need to now specify the attack type. Basically what we are doing is we are using a dictionary based hashing algorithm, trying to figure out that hashing algorithm, because I can try to brute force, but then if the character is too long, it's going to take too much of time. But rather what we'll do is we'll go through some of the popular passwords which are used in the industry and then try to generate hashes against those passwords and then try to get the password which is matching the both the hashes what we generated and what we found. Okay, so let's do that. For that we need the word list. Word list is word list equals to, which is present in the user usr, then share, then word list, and then it says rocky.txt. Now we need to specify our hash, which is hash1.txt, then press enter, which will take time for it to start cracking. So it says using default input UTF-8. Is it the expected output? Yes. So where is the password sequence? Session completed. Let's view that in full screen because I'm not used to looking at contents in such a small view. Oh, it gave us a new terminal altogether. Fine. So it's somewhere here. Is it the same thing? This one? No, that's not the password. Loaded password, yes. Warning, okay. Note the password is longer than 18 character. Worst case UTF-8, okay. Press Q or C to abort, H for help for any of those things. Also, which means it does not crack the password because it seems to be more complicated for it to solve with the default word list given to us. So what we can do is we can use a rule which will have a set of other configurations which I'm specifying for the John the Ripper tool to be using against the word list. Now what happens is, as I said, I can have my own complexities built for my password. For example, I can have A to be with 4, or they've given a better example here. A with at the rate symbol, I with the exclamatory mark, S with the dollar symbol, and all those things can be replaced. Now, for cracking this, we need to have a set of rules given to our John the Ripper to say that try to do some modifications and bring in your own complexities for cracking this password. So let's run the modified command, which is going to be John, then the same format, which is going to be raw hyphen sha 256. Then it says rule equals to word list. Let me specify that once again. Word and then list. Then word list is equal to /usr, then share, then word list. If I can spell that right, yes, word list, and then rocku.txt, hash1.txt is unknown option format. Okay, let's change that there. Yes. So loaded one password hash warning pool. Okay, will run to whatever threads. Note the password. Okay, enabling duplicate candidate password suppressor. Okay, it's suppressor. So the thing is, one more feature of John the Ripper is that once we crack the password, it's not going to crack the same password once again, or the same hash once again. The reason is to save the computer's resources, because I mean, already once the hash is known with the format, no need of cracking it once again using all the resources. So if I run the same command once again, it says no password hash left to crack. Now, if you want to see the password even after having it cracked, you can use another option called as show. Okay, I guess that's not visible in this side of the screen. So it should say --show, which is then going to show you the the hash what you cracked. So let's specify that once again. So show show hash1. Let's do that. Invalid option combination. Okay, I mean, let's just put in what here they say, which is going to be John format equals to, why do I type E there? Yeah, raw, then SHA-256, then show hash 1.txt. So now, that's not T there. So now we get the password back again, like whatever is cracked. So without that, we cannot once you crack it, you don't have to use the memory resources again for cracking the same password again. So that's their mindset of not cracking the password once again. So data breaches and hashed values. So Glitch has discovered Mayor malware's password used on the breached online form. Although there is a high chances that this password will be used to access other online accounts created by the Mayor, Glitch does not want to go that route, as it would violate the local laws and regulations. Instead of attempting anything illegal, he focused on the data he discovered in Mayor's trash. There's one interesting looking PDF file that happens to be password protected. You can help Glitch break it. The first thing you need to do is to convert the password protected file into a format that John can attack. Luckily, John the Ripper Jumbo Edition comes with the necessary tools. The different tools follow the naming style format to John. The terminal below shows the example. So the John the Ripper tool contains a list of other tools and features which enables you to get the hash of the password of that particular file using the format to John command, which is going to give you the list of hash or the hash of that file in such a way that you can then use it later for cracking it. So they've given us the example of what and all can be found, which I will showcase in another window. So let's do ls opt and then John. Let me not specify two slashes but one. So John, and then it says everything asterisk to John, another asterisk. So here you can see all the kind of tools which we can use for converting, like PDF to john.pl, PDF to john.py, or something like that, radius to john.py, and all those files which will convert those specific files into something which John the Ripper can attack and then crack the password. So in our case, we will be converting the PDF into getting those hashes basically. So you are interested in the password hash, password protected PDF. Therefore, PDF to John PL should do the job perfectly for you. In the terminal below, you can see how to create hash challenge from a PDF file. This hashed value can later be fed to John to crack it. The first step to consider trying the long word list such as rocky.txt. Moreover, you might even use the rules such as rule word list to test derived password. In this case, neither approach works. Mayor malware has picked a password that does not exist in these public word list and is not derived from any word found there. Knowing Mayor malware, we see what he holds dear. We can hint at what he would consider for his password. Therefore, you need to create your own word list with the following words: fluffy, fluffy cat, mayor malware, and save it as wordlist.txt. We have saved the above word list in home AOC wordlist.txt file for your convenience. Consequently, our command would be this. Okay. So now it just gives a description of the command. Now you have gained all the necessary knowledge to tackle the question below and uncover what Maya malware has been hiding in its password protected document. Okay, so crack the hash value stored in the hash1.txt. What is the password? What was the password? And what is the flag on top of the private PDF file? Okay, so first of all, let's see if we have the hash file with us. So we have the word list and we have hash id.py and private.pdf. So what is an example of files? Let's see there. So example files, it says Feroda. Okay, this is just an example for us to look at or test with the examples what they gave. So we have private.pdf file with us. So let's first get the hash of this file. So we'll run the command pdf to john.pl, then private pdf. Then let's put this content whatever hash we get into pdf.hash and then press enter. So now I can see the file pdf.hash. Let me print that command. Let me print that file. So pdf.hash. So this is the hash of the PDF file that we captured. So now what we'll do is let's crack the hash using the John the Ripper tool. So what we'll do is run the command John rule is equal to single. They're using the single rule. Okay, let's follow that. A single, then the word list. Let me put that in the above of the terminal. So word list equals to word list .txt, then pdf dot hash. Now pressing enter, we got the password, which is mayor malware. So let's copy that. Just selecting will copy it. So let's copy that and paste it in here. With that, we know why is there a white space. Okay, crack the value stored in #1. Oh, okay. It was not this then. So let's show the password what we captured earlier. Let's try seeing that. This is fluffy. No, just the whatever is in the box. Fluffy cat 12. That's right. So what is the flag at the top of the private .pdf file? So we need to look at the file name. What is the sorry, the contents inside the file. So let's copy that. Let's try to run the command. How do we run it? Have they given us help? After discovering the password of the PDF file, use the following command to convert it to a text file. So you can you can read it on the console. So PDF to text private PDF, then UPW password afterwards. Okay. So PDF to text and then private PDF. It gave me a warning. I just hope. Let me paste the password in here just in case. Oh no. Then hyphen. What is it? Hyphen UPW. So UPW and then the password. Then press enter. Then we should be able to see some text file here which says private.txt. So let's print that out. Cat private.txt. Okay, so this is a lot of information here. It's anyway in the top, right? So let's do head and then private .txt. So we got the flag in here. Let's copy that and paste it, replace it with whatever content we pasted there and click on submit. Oh yes, we got the flag of this room. So with that, we have finished the day 23 of Advent of Cyber 2024 of TryHackMe. So tomorrow is the final day of Advent of Cyber 2024. And I'm really excited to see the last day. How is it going to be turning out? What is the story of the final day? Hope you are all excited for the same. I am. With that, I would like to end this video by saying you all to like, share and subscribe to this channel. With that, wish you all a happy Christmas. There's one more day for pending for that, but still, yeah, happy Christmas. Enjoying your holidays. I hope you're doing it. Okay then, bye-bye. With